Say that you are a chemist trying to explain how chemical bonds form. The easiest way would be to draw a picture, right? That's the same line of reasoning G and Lewis used when explaining chemical bonding. These structures are known today as Lewis dot structures. But first, we need to understand two things: what an electron is and what a valence electron is. An electron is a negatively charged subatomic particle that exists in orbitals around the nucleus of an atom. Imagine that there is a piece of gum sticking the electrons to the nucleus. The gum is really thin for the outermost electrons compared to the other ones. Therefore, it is easier for the outermost electrons to break off and participate in bonding. We call these electrons valence electrons. So, now that we know what valence electrons are, how do we count them? Using a periodic table, of course. The group determines the number of valence electrons. If an element is in group 1A, then it has one valence electron. If it's in 2A, it has two valence electrons, and so on. Now we're ready to draw our Lewis dot structure. Let's do two examples, sodium and chlorine. Sodium, or Na, is in group 1A, so it has one valence electron. Therefore, we write Na on the center of our paper. Since it has one valence electron, we put a dot at the top. Chlorine, or Cl, is in group 7A, so it has 7 valence electrons. Therefore, we write Cl in the center. Starting at the top, we place a dot in a clockwise manner around the Cl, doubling up once we've been around the element once. All atoms want a full outer shell, often in the form of an octet or 8 valence electrons, as that is the most stable energy configuration. You can think of bonding as two elements entering a roommate agreement together, where they transfer or share their valence electrons in order to keep everyone happy. If it's a bond between a metal and a nonmetal, then the electrons are transferred. If it's a nonmetal with a nonmetal, then the electrons are shared. Let's take a classic covalent compound, carbon dioxide. First, we draw the element symbols, O, C, O. The C goes in the center because reasons. Then, we count the number of valence electrons between all the elements. Oxygen has 6, and carbon has 4, so we have 16 valence electrons to work with. Next, we draw a line between each O and the C. This represents a bond and uses 4 of our available valence electrons. This means that we have 12 left. Next, we allocate the rest of them between each of the elements, starting with the 2 oxygens. We give them electrons until we reach the full octet. As you can see, the carbon only has 4 electrons around it, which means that it is missing an octet. To fix this, we take one of the electron pairs from the oxygen and use it to make another bond with the carbon. We repeat this action with the other oxygen. Now all of the elements have a full octet and everyone is happy.